So in this section, I'm going to tell you the simple story of how stress impacts the immune system, and then in the next section, I'll complicate that a bit with some of our newer understandings of how the immune system and stress interact. But this is the sort of broad strokes picture here. So first, if we want to think about the impact of stress on the immune system, we should go back to the Key-Kolk laser studies. There's a series of studies that were done in 1986. I'm going to present just one of those studies to you. And so if you're interested in looking at stress, a great population to study is students, right? You are all very stressed. You have stressful events that happen at really predictable intervals when you have exams, and so they took advantage of this in this study and studied these poor medical students who were really stressed about their upcoming medical exams. And so in this study, what they did is they did blood assays of everybody. So they drew blood and they looked at levels of certain T lymphocytes or T white blood cells and T cells in the blood. And so what we again would expect is that at baseline, there would be, a moderate level of those. When you're not very stressed and you're not engaged in any particular stressful task or activity, you should have a moderate to low level of those. But then when you are exposed to a stressor, then those should go very high, right? But what we're looking at here is just what's happening to those levels due to stress, right? There's no specific exposure here in these studies. They're just looking at how stress impacts levels of these T lymphocytes. And so what they find here is you can look at, again, these are participants who are all medical students. They take these blood assays. They look at helper T cells as well as suppressor T cells. For our purposes, it's really not important specifically what these are, but these are all important parts of the immune system. And so what we're looking at here is that helper T cells having high levels of this is going to be a good thing, and suppressor T cells high levels is going to be a bad thing in this case. And so what we're looking at here is their levels of the percent helper cells at baseline and during the exam. And so what you can see is that that has gone down. And so were they to be exposed to some type of pathogen here, they have fewer T cells available to help to fight that off. The second graph is showing the exact same pattern of responses, showing that the immune system is compromised during this exam time, but it's also just taking into account the ratio of helper versus suppressor cells and showing that even when you take into account the activation of suppressor cells, we're still seeing the same immunocompromised here. Right, so relative to baseline, to the exam, they have lower immunocompetence. They have fewer T cells and that are available to help out with the immune system response, and so therefore these people were more likely to get sick during that time, and indeed that's what they found. Another series of really famous studies are called the Pittsburgh cold studies, and these were done in 2005, so a little more recently. And what they did here was they examined psychological factors that could influence the susceptibility of catching a cold. So unlike in the last series of studies where they just looked at a time when people were likely to be stressed versus not, here they actually are exposing people to a cold virus and seeing how levels of stress that they have experienced prior to that influences their susceptibility of coming down with this cold. And so they did this in a couple of different ways. In one study, they looked at the number of stressful life events people had experienced in the recent past, and the other, they looked at the duration of those stressors, and so how long those had been. And so if we're expecting stress to impact immunity, right, if we go back to our first lecture with the 7 criteria, we should see a dose-dependent response, right? If more stress should lead to more immunosuppression. If stress is really a risk factor for immune suppression, then we should see more of it is more of a problem. And indeed, that's what these studies show. So looking at first the number of stressful events, so participants rated how many of these things on a whole list of stressful things that can happen to you had occurred to them. And so they looked at this, and so you can see how many of these stressful events they had experienced in the past year, and so people who had experienced more, between 11 and 12, were significantly more likely to come down with a cold than people who had experienced fewer. But interestingly and importantly, right, even people who had experienced extreme amount of stress, remember they're all exposed to the cold virus, still only 50% of them get cold. So it's not saying that everyone who's stressed and exposed to the cold virus will automatically get a cold, but it's much more likely here than for people who had fewer stressors but were also exposed to the cold virus, right? They literally take a little nasal thing and shoot the cold virus up your nose, so the rhinovirus, and everyone is exposed. In another one, a very similar study, they looked at how long those stressors had lasted, right? So you could have many stressors, but maybe they're all very short, or maybe you've had, a really long stressor where you've been caring for a chronically ill family member for a year, right? So you could think about how long this stress has gone on, and this is what they did here. So people who had no long-term stress, no chronic stress, ones that had lasted less than a month, more than a month, but less than 6 months, and so on and so forth, and ones that had lasted more than 2 years. And what we see here is that this also linearly affected the risk of developing a cold. So all of these people were exposed to the rhinovirus, and those who had had the longest duration stressors were the most likely to come down with the cold. So again, that's showing that dose-dependent response here. But importantly, as I said before, not everybody got a cold, even those who were the most susceptible, right? They had high levels of stress and they were exposed, but even then, not everybody gets it. And this goes back to this idea of this diathesis stress model, and it assumes that two factors produce disease. And this is the idea that the person has to have a predisposition or a diathesis to the disease, and this can be the biochemical predisposition. Maybe it's that exposure to the virus that we just gave you in this study. We actually put it up your nose, or maybe it's some other type of genetic vulnerability. Like clearly I have a genetic vulnerability to autoimmune disorders, and so this could be that predisposition. And then you combine that with some experience of stress, and this is what leads to the propensity to come down with an illness or to become sick. But again, as we said, not everybody gets that, and so there do seem to be some important protective factors that can mitigate the impact of stress. And these are some of the things that we talked about in the coping lecture, specifically social support. Right? And so I'll talk a little bit towards the end of this lecture about the article that you read for today's lecture and that you're discussing with your groups this week, but that's showing an example of how felt loneliness can really impact our experiences with the cold virus. And other studies have shown that social support can mitigate many of the negative impacts of stress. So in this next section, I'm going to really complicate what's going on with stress in the immune system and add some nuanced factors here. So first, comes from your reading, but something I want to reiterate here. So really, a key player in this relation between the stress and the immune system is glucocorticoids, or cortisol, we can call it. That's the specific one that we're looking at here. And glucocorticoids have an impact on the immune system through a number of pathways. First, they directly shrink the thymus gland, which is an important part of the immune system that creates new lymphocytes or white blood cells. Again, those key players in the immune system, T cells are lymphocytes, B cells are lymphocytes, macrophages and phagocytes are lymphocytes. So all those key cells in the immune system are less likely to be created and formed when we have high levels of cortisol. It also blocks the release of interleukins and interferons, some of those chemical messengers, right, that are part of the immune system's communication. And so this makes those lymphocytes then less responsive. They're not getting the messages that they're supposed to get, and so they're not responding in the way that they're supposed to be responding. Glucocorticoids also remove some lymphocytes from circulation, so they're just not there to operate in the way that they're supposed to operate. And then lastly, it also directly kills some of the important T lymphocytes. And so glucocorticoids have a really negative impact on the immune system. And that's in keeping with what we've shown so far, right? When people were really stressed with an exam, many stressors in their life, and then they're exposed to a cold, they're more likely to get sick because they've had a lot of cortisol and it's really dampened their immune system. And so it's less responsive to fight off any threats. So that, again, is the simple story of how stress impacts the immune system. But it turns out that it's actually a bit more complicated than that, right? When we first talked about stress and what stress does to the body, we said that it shuts down the immune system because, you don't really need to worry about cancer when you're running away from a lion. But it turns out that that's not actually true. We thought that was true for many years because most of the studies about stress were things like the ones we just talked about, where you look at a major stressor like taking a big exam for these medical students, or you look at people who are grieving a loved one, or you look at people under these long-term major stressors. And so certainly then when we look at those, we do see a lot of release of cortisol, glucocorticoids, and this suppresses the immune system. But it turns out if we look at more subtle stressors, or we look at stress with a finer lens in terms of time, and we look at what's happening immediately after you're exposed to a stressor, not a ways out, that we actually see a different pattern. And Sapolsky talks some about this in his chapter that you read for today. But what we show when we look at this, when we look more closely at what happens with stress, is so here's your immune functioning at its baseline. It's functioning well, 100%. It's great. And there's an onset of a stressor. And immediately after the onset of the stressor, our immune system actually ramps up and becomes more active during that time. And so we see an increase in immune functioning. And then it's really when that stressor becomes more prolonged and then moves into the chronic stage that we start to see the suppressing of the immune function, right? So this is when that HPA axis is starting to come online and more cortisol is being released, right? And so that would seem like that would be a bad thing, right? We don't want cortisol, it's suppressing our immune system. But originally, in many cases, this is adaptive, right? We don't, as we'll see in a future slide, we don't want our immune system to keep going up and up and up and becoming more and more functional, because then it's going to start to become, really oversensitive, and we're more likely to develop autoimmune disorders and other issues with an overactive immune system. So the cortisol should actually tell the immune system to come back down, and ideally that stress then ends after it's moderately prolonged and you come back to your baseline of 100% immune functioning. But often, when we're exposed to chronic stressors, things that last a long time or are very stressful, then we have a lot of release of glucocorticoids, and so we fall down past that point of 100% immune functioning, and we see major immune suppression. And that's when we see, like in the studies that we talked about, where people are showing suppressed levels of T cells and are more likely to become ill. It's really, when we thought we were looking at just stress before, we were really looking at chronic stress. And so now we know that there's a much more nuanced pattern of actually you have an increase in immune functioning initially at the onset of the stressor, and then it's really when that moves into becoming a chronic stressor over time, and you have large amounts of cortisol pulsing through the body that suppresses immune function greatly. And so another important and interesting thing about this is this helps us to better understand what's happening with autoimmune disorders. And so what's happening here is that the onset of a stressor occurs, and you have an increase in immune functioning. And if you don't have the proper release of cortisol, that's not regulated properly, then you don't get this decrease in immune functioning when you should, and so you don't go back down to your optimal level of immune functioning. Instead, this could keep going up and up and up, and essentially this is what's occurring in autoimmune disorders. Is you're having an overactive immune system. The cortisol system is not working properly to tell your body to stop doing that, and so it starts to become oversensitive and is more likely then to attack itself. And this is when people get things like ulcerative colitis and rheumatoid arthritis and psoriasis. But then it turns out it's actually even just a little bit more complicated than that it's really not so much about, sorry, I should jump back a second here. And so with autoimmune disorders, this is we have this major increase in immune functioning. It becomes oversensitive, and we don't have the release of cortisol that should bring us back down. And that's why one of the major treatments for autoimmune disorders is to give people steroids. And what these are is they're giving them cortisol. You're giving them high levels of cortisol or immunosuppressants like we talked about before, and that just suppresses the immune system, and so that will bring you back down here. You no longer have an overactive immune system or an autoimmune disorder, but it can really compromise your immune system in other ways, such that now you're not able to fight off other things. And so while you might not have your autoimmune disorder symptoms when you're down here with lots of cortisol, you are more susceptible to coming down with other illnesses. So it's a trade-off with those kind of medications, and so we use them when you have a severe autoimmune disorder, where those symptoms are worse than the risk of contracting other illnesses. So again, I was going to say it's even just a little bit more complicated than that, right? We don't usually just have like one stressor that's really major, and then we get it up into our autoimmune disease range. It seems that this is actually really likely to occur when we have many short-term stressors in close succession. So looking something more like this, that, if often when we think of chronic stress, right, we might think we're chronically stressed in grad school, but really what's going on is it's actually a series of stressors, right? It's you have to put this proposal in, then you have a meeting with your advisor, then you have this talk you have to give, then there's a test, then there's this other thing, right? It's actually a series of smaller stressors. And so what happens with each of those, right, is our immune system starts to go up, like it should at the onset of the stressor, and then if the next stressor occurs too quickly, and our body is not doing a good job of releasing cortisol to tell us to go back down to our 100% range, then with each stressor coming on, we're going to slowly ratchet the system up until we get into this autoimmune disease range, right? So after each stressor, rather than coming all the way back down to our 100% baseline and then going back up, we're slowly moving up here into the autoimmune disease range. And so we're not sure at this point totally why some people are more prone to this than others. Certainly there's a genetic factor there, but it seems to have to do in part with the regulation of the cortisol cycle, right? So for some people, their body is much better at getting it back down to this baseline here, whereas for others of us, it takes a longer time. And so when we have many stressors occurring in a row, we get up into this autoimmune disease range. And so this accounts for this really counterintuitive or almost seemingly contradictory effect of stress on autoimmune disorders, where stress can both, lead the autoimmune disorder to become worse or to get one, right? When you have many stressors in a row. And so people often report when they feel more stressed, their autoimmune disorder flares up. That's definitely true for me. But at the same time, if you experience a lot of stress, or you get really sick and you suppress your immune system from that, actually autoimmune disorder symptoms get better. When people are under a really major stress or really chronically stressed, their immune functioning actually, their autoimmune disorder gets better. And again, this is why we take advantage of that and give people cortisol steroids to artificially induce that and to treat really severe autoimmune disorders. So that's the more nuanced version of what's happening with our immune system. So I'm going to end this section here, and then we'll pick up with talking about stress and cancer.